Welcome, homeowners and HVAC technicians. Today what we're going to learn about is how to test a capacitor, run capacitor, and a dual capacitor to find out if it's bad. Now what we're looking at is we're actually going to test these under load so we can figure out and narrow it down more simply. That way we can rule out a bunch of different factors that it could be, especially when your system is not coming on. So let's take a look and find out everything you need to do and what you will need. Okay, now remember, and this goes for technicians as well, especially since you get out there and you're kind of working on someone's unit by yourself for the first time, we tend to forget about basics. Just as a side note to homeowners, make sure that you have your voltmeter. Now, you're going to need a clamp meter for this test because we're going to need to take an amp draw. You don't have to have this more expensive meter. You can get some, I think Harbor Freight has them for around $15. Something that's simple, that's going to do an amp draw and your volt reading. This has the capability of also reading microfarad, but since we're learning how to do this without the microfarad setting on your meter, we're going to ignore that for today. So back to the basics. When you get there and you do put your meter to check the capacitor, always make sure that you do have power. It sounds ridiculous, but you need to check. You should have something out there like this, and remember, not all units are the same. You need to make sure that you have both your 24 volts on your low side voltage, your contactor is in fact engaging or pulling in, and that you do have 240 volts coming in and 240 volts coming out. Just to show you what an engaged contactor looks like, let me pull my power over here. On your contactor, you're going to have two thin wires. These are your 24 volts or your low voltage that sends the control voltage or low voltage out to the unit to let it know it needs to come on. So there's one side, and remember, your contactor might not look like this. It could have just the one hole and one that has a solid leg or a shunt leg here. You can also have your 24 volts just on one side. So remember, this might not look exactly like yours. When it is receiving the signal for the 24 volts, this will pull in. And as you can hear, it makes a fairly loud click. It's an audible click. If that is not pulling in on your unit, you do not have your low side power coming out to the contactor. So as homeowners, where do you put your leads in order to check for power? From your disconnect going into your unit, there should be 230 volts here to 40 volts already. So when that 24 volts is sent out to the unit, that is when this actually engages and those contact points connect, it arcs and burns, and then the 240 comes through into the unit to turn on your compressor and your fan motor. So this has to engage before anything will come on. So if absolutely nothing is coming on, always check power first before moving on to the capacitor. This will save you a lot of time. When you're checking for power, you not only need to check for power coming in to your contactor, you need to also make sure that there is power coming out. Because even if these are pulling in and these are engaged, it doesn't mean it's making a good connection to allow that entire 240 volts to come out. So you need to make sure that you are checking for this. And here's how. For this test, these are going to be color-coded on most meters. You're going to turn your meter over to volts AC. Now, some meters have a bunch of different numbers. Just look for the volts AC symbol and just crank it up to whatever the highest number is that's on there. We're going to turn on our power, and what we're going to do when we're testing with our leads is we need to have one on each one of these poles. Okay, we're not checking like this or this. To find out if we're getting power in and power out, we're going to do one here and one here. And no, if you're asking about color here, that doesn't matter. Just one here and one here. And then we're going to turn on our power. Now remember, if you have pulled your disconnect box, you know, you've pulled it out, or if yours is kind of like a breaker where you turn it on and off, this isn't going to work. You need to make sure the power is on before you do this test. So put that back in there. Obviously, safety first. Make sure you're not actually touching any part of this or any part that is the live voltage. So just be safe. One lead on each. And there we go. Should be around 240 to 245 volts AC. So now, as I mentioned before, if this is not pulling in, you can stop right there. You don't even need to check just yet until you fix what's going on here. And that is, this has got to engage in order for your system to come on and function normally. This is your thermostat saying, hey, it's, you know, we're calling for air conditioning, so let's go ahead and turn the unit on. So if you see that this is not pulled in, you've got a break somewhere in your 24 volt line, or your thermostat is not calling for cooling like it should. Okay, so we apply our 24 volts. Now, if you just want to check, and you are checking for 24 volts on our system, remember, again, yours might be just on one side. It might look different. That's fine. But we're just checking. 27 volts. Perfect. Somewhere between 26 to 28. Okay, so now that we know we are getting our 24 volts AC, we know we are getting our 230 or 240 volts in. Now we need to see if the contactor is allowing the 240 volts out. So we're going to put our leads, again, one on each side. Doesn't matter which side you do it, as long as one touches each side. You can also put them down here on these poles. I'm just doing this because it's easier for me to do this while I'm pushing the power button. Okay, so now we're going to hit our power. Perfect. 245 volts. We are good to go on that end. So now we can rule this out. And I know this is we're testing our capacitor video, but it's important to touch on these sort of things just so we don't waste your time when you're diagnosing. Hey guys, remember math? Well, we're going to have to use that today, because if you do not have the convenience of a voltmeter that can read microfarads, we're going to have to do a simple math formula and an amp draw. So our formula to figure out microfarad, now remember, this is kind of an ish, it's not perfect, but we'll definitely know if your capacitor is bad. It's going to be our amps, you know, let's just say something like 7.8, amps. We're going to multiply whatever you've got here from your amp draw times 2,000 652. Once you've got that number, we're going to divide all this by the voltage that you get across your capacitor between your start and your run. So whatever this number may be and whatever your amp draw is, that is what we're going to first multiply and then divide. This is your voltage here. So let's take a look at what that looks like in real life, because on paper it looks a little intimidating. All right, let's take note. First thing, we need to get all of our information before we can find out what it is, we're even looking for. On capacitors, what is very important here is we need to know what our compressor is going to take, which is a 65 microfarad according to this capacitor, and the motor would be taking a 10. And that's what these numbers are. It's the amount of microfarad, which is also this. UF is the symbol for microfarad. And so we're trying to find out if this is within spec. So we first need to know what our microfarads are. Then we need to know plus or minus. So if this is within tolerance, once we do our formula, this specifically, this brand is saying theirs is 6%. It's whatever the manufacturer decides that capacitor should be within. Most of the time I see plus or minus 5 or plus or minus 6. So we need to know that it's a plus or minus 6%, that the capacitor, no matter what numbers you have here, you could have a 45 plus 5. Some of them actually write it this way, a 545, which is fine. It just means the lower numbers for your motor and the higher numbers for your compressor. Now, even though it says, say, 370 or 440 volts AC, this is not the AC that we're checking for when we're going to check our voltage across the capacitor here. So when I say we're checking voltage, we're not checking the voltage based off of what the capacitor is saying. This is the threshold which the capacitor would pop if it reached above this voltage. So that's what that number means, just FYI. So once we get our information here and we know what it is we're looking for, we write that down. All right, so this one, Trade Pro, they like to put this cover over here, so it's kind of hard to make out what we're looking at on this label. So if you can kind of tilt it a little bit here, you can see HERM, or hermetically sealed compressor. I know a lot of people get confused here because you would think C would actually be compressor, but no, this actually means common. And then fan, which is the start winding of your fan motor. Now, if you've got a 3-wire setup, again, colors of wires do not mean anything. Your motor wire can be purple that goes to C, it can be red, it can be orange. It's whatever color the manufacturer decided to make their common wire or their line. So you'll have one on your fan and one on your C, and those both go to the motor. On here is your compressor wire. So when we are checking voltage, depending on what we're checking voltage to, that's what we're going to go across. We're checking from voltage to the start winding on our motor and voltage to the start winding on our compressor. So what we're wanting to do here is let's go ahead and get our amp draw first, and then we can go ahead and check our voltage. While we are doing this, this is going to be our amp draw as we mentioned. We're going to take our clamp meter and we're going to make sure that it is on amp draw. This stands for amps AC. So that's what our clamp meter is for and why you need to have a clamp meter in order to test this even for your capacitance. So this is the start winding of the motor. This is the one that's going to be labeled fan on your capacitor. So you checked everything for power, you know you've got power coming in, and when we check for voltage, in which you can do this in either order, it doesn't have to be one way or the other, because what we're doing is we're just testing. You're going to be able to get more of an accurate reading because you're going to be able to float this more towards the center than I can on this table. But once we have our start winding through the center of our clamp meter, we're looking for our amp draw. Now on the side of your motor labels, it will actually list an amp draw. So you can also see if your motor is overamping, because that's usually kind of a good sign that something's going on with the motor or the capacitor. So we're going to turn this on here. And remember, when a motor is under a load, like the fan is on there, it's attached to the cover, it's going to read a little differently. This one currently is reading 1.58 amps. And you're going to let that run for a little bit just so you do actually get an accurate amp draw. So once we know, we're going to write that down, 1.5 amps. Now some of you might have your motor, because there are some train units, American Standard units that do this, Carrier, where you're on a 3-wire setup with a 2-pole capacitor, or you have 2 going to this style capacitor, and you're not sure which one is going to be your start winding. Don't worry, I've got you. We'll talk about that in just a moment. It's not all capacitors are the same. So now that we know our amp draw, and again, checking for voltage or checking the amp draw, there's no order to either one. You can do that, either way you'd like. So once we know our amp draw and we know what the capacitor is supposed to be, we know we have power. Now we're going to check the voltage across the capacitor to make sure that it is boosting like it should. It will not read 240 volts because a capacitor's job is to boost. It's going to boost the voltage. Now when we're checking voltage, what we're going to do is we're going to turn our settings over to volts AC. Yours could have a V with the alternating current symbol next to it. And like we'd mentioned before, just turn it up to the highest number that's on there, 2000, whatever it goes up to, just turn it to that setting. And that's what we're going to check. So, Crystal, where do we put our leads to figure out the voltage? Okay, and now let's get the last part of our equation. We have our amps. We know how much we're going to multiply it by, and we're going to place our leads here. So one here on common, one here on fan. Now remember, this is going to be high voltage, so be cautious and make sure you're not touching any of the high voltage wires. So now we're going to get our voltage here. And there we are. It's 387 volts AC. So now we're going to fill the last part of that equation. We know that it's 387 volts after our boost. So let's plug that in and see if our capacitor is within spec. So keep in mind that you can do the same formula when you're checking your compressor. The start winding on your compressor is the one that's on your HRM terminal. So when you're checking your compressor, you're going to check between your C, and obviously I don't have a compressor hooked up here. It's a little impractical for our office. I could go out to the unit outside, but just for simplicity's sake, you know how to check fan. So now you're going to apply that same knowledge to checking your HRM. So you'd put your one lead on HRM and your one lead on common and apply that to this same formula. So remember, again, it's going to be your amp draw times 2,652, and then you're going to divide that by the voltage across your capacitor, which is going to be from your common to your fan, and then from your common to your HRM. Once you plug this in, now even though most manufacturers say plus or minus 5% or 6%, honestly, you can go with 10% and it's going to be in spec. So make sure that it is adding up, the numbers are adding up, and this is perfectly within spec. Even though it's a little over, that's completely fine for it to be a little overcharged. Now, for those of you that don't want to have to go through, figuring out how to multiply 6%, 5%, 10%, I actually had to kind of think about this for a second because it's been a bit. But the one that you're going to multiply it by, we'll just round it and say it's supposed to be 10, right? For, again, simplicity, rounding it out. You can do it by 11, whatever you'd like to do. But that one, when you're multiplying it by the microfarad reading you got, that's your unit, your 1 unit of 10. And then that second number is going to be what that percentage is. So 6%, decimal form, 0.6. 5%, decimal form, that's your percent. Within 10%, 1.10. You get the picture. So if you're wanting to multiply that on your calculator to figure out if it is in spec, that's what you're going to multiply it by. What if you don't have a dual run capacitor like this one? Well, it's going to make your life a little more difficult, but something you need to know before you start testing these and before you start trying to test both of them is one or the other part of your machine not coming on. For example, if your motor isn't coming on, but your compressor is, what we're going to do is we can do the same reading for the run capacitor, and then if it's, say, your compressor not coming on, and some of the older units, instead of having just this one capacitor in there, it will have two. It'll have this one for your fan motor, and instead of 3 poles on top like this one, a compressor, just one for your compressor, is going to be a larger, it could be oval shaped, it could be circular, but it'll just have the 2 on the top that you're going to check. But how do you know what your start winding is on a 2-wire setup like that? Well, here's how. So what do you do if you have 2 solid color wires going to the capacitor? They've actually made this simple for you. so you know which one is the same wire there. That white stripe lets us know that's where the line of power is coming through. It's the same as this wire. But what happens if these are both solid blue, solid purple, or solid brown? You're not going to be able to know which one it is. So you'll have one on each like this. What we're going to be doing is we're going to check each of these wires for resistance against the winding on the motor. That would be C here on your common. And you can also check it against your other leg of power and find the resistance between these two to find out which one is actually your start versus your power. So we've got our clamp meter set to the find out the resistance, your ohms here. And what we're going to do is test against these windings to find out which is your start. So just to kind of show you how these two wires are the same wire, if you were to test them against each other, just for fun here, you can see there is little to no resistance between these two because it is the same wire. So because of that, you know that these are the same wire. So if you take this off of that capacitor and it has that really low resistance like that, you now know that this has to be your start winding. And so we place one lead on each between these wires, and we can see that it has a higher resistance. So, which one of these is going to be your common when you're checking it? Well, interestingly enough, you check here between your start and your other leg of power, your other power winding here. You can see, although it's not the same, it's still going to read a fairly high resistance. It's going to be different because this is a different winding for the power, but it's still going to read high versus, again, if you were reading something like your C, your common, to the same wire, which is 0.08. So as you can see, you now know that your start winding is always going to read higher when you're checking it against the C wire on your capacitor, or when you're pulling one of these two wires off of here against the wire either going to a C if you have a 3-wire setup, or if one of these wires that is your other leg of power is going back to your contactor. So you could essentially test both of these wires against your legs of power from the motor. And not all motor wires, get this darn thing on here, go to the same spot. If it's got a capacitor off to the side for the motor, it could be that this is just a universal motor. If you have both this style beside your dual capacitor. So if you don't have one of your motor wires going to the capacitor, that's okay. You can check it out against the wires that go to the contactor, because a lot of times it's easy to just put those 2 wires here that makes your 240, and then 2 wires here that's your line through. It's a more simplified way to get power to the motor, and then just 2 here. simple. But like I said, there are some that will look like this. So just check the wires that are going back to the motor, and you're going to check both of these against that wire that goes to the C, or the wires that go into your contactor. If it has a higher resistance, that is going to be your start winding. So what happens if you test your capacitor and it's within spec, and you know, again, we have checked for our power, and we know we're getting power in, power out, and that this is pulling in and engaging. We know we are getting power here by testing against our C and our fan and our C and our Herm. We know we are getting voltage there. That is now going to be something else. Now, is it one or the other? Is it your compressor that's not coming on? Okay, so check the amp draw on your compressor when your system is on. Is it open? Is there no reading? And that's your answer. There's an open winding on your compressor. Same goes for your motor wire. If you place your amp reader here, your clamp meter, and it's open, you're not getting an amp draw from it, and it is definitely getting power, and we now know that the capacitor is good. Well, there's an open winding on your motor, and your motor is bad. Well, guys, I hope this has been helpful for you, and as always, if you have any questions or something wasn't covered, just leave a comment below and I will get to them as soon as possible. Thank you so much, and have a wonderful rest of your week. Take care.